Good morning, everyone. I'm Monse Estaca, head of telematic area in the Spanish Directorate of Traffic and responsible of the development of the NAP and the connected vehicle platform. And here with me is Antonio Granado, who is the director of the Southwest Traffic Management Center that you have been able to visit these days. In this presentation, we are going to share the two flagship projects at the Directorate General of Traffic to contribute to enhance traffic management and safety, the connected vehicle platform, DGT 3.0, and SCADA DGT. Let's start with who we are. DGT is a public authority, part of the Interior Ministry, responsible of the traffic control and surveillance, including the regulation and fine in the Spanish interurban roads, with a section of two regions, Catalunya and País Vasco, the management of the 8 traffic management centers, and the collection and publication of real-time data. DGT runs the National Access Point of Mobility created by European mandate. Some relevant figures that we can comment are: we have 50,000 kilometers of interurban roads with ITS equipment, 2,400 variable message signs, 2,200 cameras, and 2,800 roadside data collection equipment deployed in the main roads. This is the general traffic ecosystems here in Spain. This is how it works. There are the two main tools. The first is Lince, which is the incidents management tool that provides real-time information to NAT every minute. And the second one is the SCADA DGT that supplies real-time information to variable message signs. Lince is fed by several sources from TMC, police, traffic police, SCADA, DGT 3.0, which is the connected vehicle platform, and other internal and external apps like Traza, Reno, or Waze. In this slide, you can see the national traffic access point in Spain. There is the relevant information that we provide. We provide interurban traffic incidents every minute, maximum speed limits. Nowadays, we provide minimum speed limits, but we are develop a guidelines to improve this information in T and ITS. We also offer the low emission zones. In Spain, it's compulsory that the cities provides that information, and we also are providing vehicles electric charging points. And let's start with one of the projects that we have. We are going to talk about the connected vehicle platform. For those who don't know exactly what is the connected vehicle platform, let me introduce it. The platform integrates, standardizes, and makes mobility data available in a trustful, open, and free way. This platform is pioneering and a benchmark public service in Europe, available for all the actors that are part of the mobility system, from national, regional, and local authorities to vehicle manufacturers, service providers, public transport platforms, etc. This platform also contributes to the national access point. Some of the goals that follows this platform and shares with DGT are: reduce accidents, warning users in real time of the risks they may encounter on their journeys, improve traffic flow and efficiency in operations. We believe that a driver who knows in advance what is happening on the roads can make better decisions, and we contribute to emission-free mobility. The service available in the platform are these that you can see on the slide. We have interurban, in interurban roads, we have low emission zones, parkings, and loading and uploading zones information. These use cases are developed in collaborations with local authorities. We also have a mix with urban and interurban roads, V16, stop vehicle, expo events, and connected cones in construction zones. And finally, the use case developed on interurban roads are tow truck roadside assistance vehicles in operations, V2, tracking a large transport, emergency vehicle approaching, cyclists on the roads, protecting vulnerable users, and finally, bus in bus stop. I'm going to explain with some detail 4 of these use cases. These are 2 iconographies of the use cases that we have developed for urban and interurban areas. And we start with V16 stop vehicle. We consider that one of the most dangerous problems, situations that you can find on the roads are when someone leaves his car because there is a breakdown in their car. They have to walk to use warning triangles, and this situation is very dangerous. Because of that, Spanish government has decided to replace the warning triangles using V16. The use case is the service provides collects information of all the breakdowns or accidents that happens on the roads because of a vehicle or a load that obstructs the roadway. This is the legal framework. I consider very important to mention the United Nations Regulation number 48 that says that all the drivers should advise of a breakdown with warning triangles or other devices. These other devices includes the V16. The new V16 is an IoT device. Flashing light replace the warning triangles as a means of signaling a stationary vehicle on the road. You have to put the V16 on the top of your roof of your car, and it's going to be mandatory for Spanish registered vehicles since 1st January 2026. Which are the functionalities, the fundamental aspects of this signal? It can be installed without the need to exit the vehicle, which provides greater safety and convenience for drivers. It increases the physical visibility of broke down vehicles on the road. The device increases the visibility from 100 meters with warning triangles to 1,000 meters with this device. It creates a new concept of virtual visibility, as the data can be consumed from NAP by service providers. And it democratizes connectivity, making connectivity available to all vehicles, both new and old, regardless the model or range. And it is universal. It can be used by drivers with reduced mobility. The graph shows the number of V16 signals activated in the last 12 months. We have reached peaks of 10,000 signals per month. The map shows the signals activated last Saturday at 15:30, I think so. We have another use case, which is the connected cone construction zones. The service provides centralized access to information on road impact caused by the works, which we have submitted to the DGT during the authorization and planning process through the TRAZA applications. The legal framework is there. And the connected cone is a self-contained Flagship IoT device that transmits the exact location, inferring the locate of the roadworks. It also creates the new concept of virtual visibility. A new use case is tow truck roadside assistance vehicles in operations. In Spain, it's compulsory that the tow trucks send the geoposition information to the NAP. We are receiving more than 300,000 signals per month, and you can see the image in the map that shows the tow trucks that were working last Saturday at 1 p.m. And finally, in my case, the last use case that I am going to talk about is the EVA use case. The objective is one drivers to the presence of an approaching emergency vehicle in interurban roads. The achievements improve the safety of emergency vehicles and other vehicles in the path, enhance traffic flow by allowing vehicles in the path to anticipate the situation, prioritize the movement of these emergency vehicles, which need to reduce travel times as much as possible, and to prevent accidents that may occur when vehicles and emergency vehicles are in the same path. The vehicles that will be reported in this use case are emergency vehicles with blue lights and snowplows. The data has to have special characteristics. It has to be anonymized and unobstructed, alerting only users in the path of the emergency vehicle in compliance with data protection regulations and without revealing the full path. The characteristic of the data is more strict than in other use cases. And we are developing 2 pilots. A blue light pilot with, in collaboration with 112 firefighters of Comunidad de Madrid. The main problem is the frequency. They give the frequency between 10 to 50 seconds, which is not enough. And the solution is has been to receive a polyline of the planet route. In the case of snowplows, we are also developing a pilot with Junta de Castilla y León. In this case, the main problem is that the snowplows has two modes of work. One with spreading salt with a speed between 80 to 90 kilometers per hour, and the other one with the shovel in the removing position, removing the snow, and they goes between 10 to 20 kilometers per hour. So this, the information that we receive is going to be different, and they have to switch between one mode to the other when they send us the information. And now I pass the testigo to my colleague Antonio Granados, who is going to explain about SCADA.
Well, thank you. Thank you very much. Monse, thank you very much, and congratulations for your presentation. Well, my name is Antonio, and I'm the director of the Traffic Control Management Center in the Southwest area. It's a pleasure for me to be here to explain our project, SCADA DGT. The project SCADA DGT is an ambitious project, a complex project, and we will try to explain you to our objectives, our skills, our problems, and our final results. Where in Spain, interurban traffic is managed in the traffic. There are 8 traffic management centers in Spain. The traffic where I work is located in the southwest area, and the main functions are traffic management and control, improving the road safety, and providing information and assistance to users. One characteristic is that they are operational 24 hours a day, all days in a year. Okay, this is the map with the distribution you can find on the and it's according to the distribution that Monse has said before. We are totally aligned with road safety. Our main concern is road safety. So we are aligned with European policies, and recently Spain has approved the Road Safety Strategy 2030 with the objective of our mobility secure, sustainable, and healthy, and the aim to reduce the number of deaths on roads in a 50% with a vision in 2030. It's an ambitious objective, but we have done in the previous cycle in 2020, 2020. So we are working on that. The project, the title of the project is the Development, Implementation, and Evolutionary Adaptation of Corporate SCADA and Video Streaming System of the Traffic Management Center. It's a project with a 5 years debt. This had begun in March 2023, and it will finish in 2028, and has 5 different components. We are going to go to each component. For each component, we'll try to explain. And the main objective is the implementation of a united process control system in the traffic management center. This is very important for us because in the past, we have different systems in our traffic control management centers, and unification is very important for us. The second objective is additional functionalities to our cloud environment. It's an entire cloud solution with all these advantage and disadvantage. We will go ahead right now. And it's allowed the construction of a functional ecosystem for the traffic management center. So we are going to go for the different components, okay? The first one is the unique SCADA in traffic management center. It's a new system designed and implemented especially for cloud environment. So one characteristic of the cloud and that we bring to our project is the scalability. We are able to increase our resources in function of our needs. And the second big objective is unification. All the traffic control management system, we use the same system to deploy to utilization, the IETS system, right? We are integrating right now more than 10,000 ITS systems, which is in real time. All these systems are sending real-time information, and we're in integration. We adapt to the technological adaptation. For example, we have full matrix variable measure sign support, for it's important for us. And there are more than 300 users registered and working in a continuous way for this system. We manage all the standard ITS system that are in Europe, like inductive loops, road safety system, variable measure sign, meteorological LPR. And we have 4 main objectives. First one is stability, a very important objective with critical systems. Second one is fluency. It's very important when we have a wide number of actions to do. Third one objective is error tolerance, redundancy. 2 weeks ago, we have a power supply failure in Spain that affected mainly a wide area of Spain. And the SCADA, due to its cloud characteristic, could be able to be online. We will go ahead. And the fourth is continuous evolution. At this moment, we have a standard application, and we are evolution. We had to continue evolution this application to add new functions and functionalities. The architecture of the solution is a mix. It is based on a mixed service cloud. This is not a private cloud, not a public cloud. This is a mixed cloud, and it's based on a microservices structure, which facilitates us aspects related to maintenance, deployment, or redundancy. The second component is related to video. It's a very important part in traffic control management center. And video incorporation, we have more than 2,000 cameras. And those cameras, the flow of the video is uploading to the cloud. So with 2 main objectives. The first one is video usage. We can unify the use of video in our traffic control management center. And the second one is video recording, or our camera and video recording that is important for the daily work, for incident detection, video analysis, or even we are thousands of functionalities we can do. And we have another variable that is our video signal can be deployed to external authority, to external administration in a secure way, not accessing our directly our traffic control management center. With this solution, we have two, as I said before, two aspects: internal management and external management, all in a secure way. At a level of architecture, the video signal is incorporated using standard protocols that are HTTP or RNTP protocols. We have a dedicated API for logging authentication. This is a big concern for us. Cybersecurity, so due to our solution in a cloud solution, is a big concern for us. So we have a high standard of security in the solution. We have recordings query in order to allow to access the system and recording export in a unified way. The third component is the integration or flowing card data in our solution. For us, it's important to integrate the floating card data in our SCADA with different use cases and give some consistency to the data we are. For example, some use cases we use floating card data, for example, incident data, for example, for the detection, roadworks, congestion, sudden drops in speed, real-time monitoring in component 1, and the possibility of consultation of historical data with 5 years depth in our history. So this is an important. We offer travel times in our system, for example, in two different ways. Short-term travel times we using by LPR in combination with floating card data. We have discovered that this is it has an impact on road safety because if you know the travel time to for example to go to the airport, the level of stress of the driver goes down. You know how you will arrive to that destination. And the second one is to offer better information in long-term routes. For example, from here, from Seville, we offer travel times to Cádiz, to Huelva, to the frontier from Portugal, for example. So, for example, the fourth component is associated to communication. All of our systems are communicated by optic fiber or inalambric communication, and we apply redundant procedures for that with a connected scan, as you can see on the image. And the fifth component is associated for our cloud implementation to deploy all our applications and the national access point of our administration. Okay, to finalize my presentation, I would like to take what are, from my point of view, what are the 10 main advantages. It has disadvantages too, of course, but from my point of view, what are the main advantages? Okay, to have a single SCADA for all the traffic management center is a great step in our technology, in our administration. The second point I think is important is a DGT proprietary system. We have a contract of this element that is being developed under a contract of DGT, but at the end of the contract, the source code of the application will be property of our administration, which is an important key in this element. The third point is the integration of the video subsystem, as I told before, and the integration of floating data. The fifth point is the integration of singular system. We are able to integrate individual item system, but then complex system too. For example, reversible lines, high occupation vehicles lanes, and other systems that DGT are managing here in Spain. The sixth point is the high security standard. We, at this point, we have compliance with the national security scheme. This is a very concern for us, and we have acquired the certification, which is a good point for us in order to know we are not free of a cyber attack, but we know if we with the compliance, we have the security schemes at national level, we are very we have more possibilities to solve this attack. We have redundancy orientation with the architecture. We have this before. We have integration with national access point. We have a key point for us, and we have application with big data and, and artificial intelligence application. At a final point, our main objective, as I said before, is the improved road safety solution. Road safety is important for us, and with this solution, we will improve the road safety in our traffic control management center. Thank you very much for your attention. It's for me a pleasure to present, and thank you very much, Monse, for the opportunity, and thank you very much. Bye.